Okay, so we want to graph this equation using transformations. The first thing I'll do is I'm going to rewrite this as 2, and then in the parentheses here I'm going to write this as minus e to the x plus 1. Okay, I could factor out the minus sign there, but I think I'm going to leave it like this. Now let's try to take this in stages here. So obviously this is going to look like the graph of y equals e to the x. Okay, e to the x, the exponential graph looks like that. Okay. So what's the first thing we see? Well, we see that there's a negative sign in front of that e to the x. So, right, what if we just graphed y equals negative e to the x? Well, that's, a negative sign in front of the function reflects it over the x-axis. So, what we would have, right, negative e to the x looks like this. It's a decreasing function, not an increasing function. Okay. Now what else do you see? Well, you got a minus e to the x, you got a plus 1 there. Plus 1 would shift that up 1 unit. Okay, so up 1 unit. Notice that, with the exponential graph, it goes through the point 0, comma 1. If you reflect that over, this must be the point 0, comma negative 1. And so if I shift that up 1 unit, all of a sudden now my graph goes through the origin 0, 0. Okay, it's going to have the same shape as the previous one, but it is shifted up 1 unit. And then the last thing here is, the whole thing is multiplied by 2. Okay, the whole thing multiplied by 2 means a vertical stretch by a factor of 2, which essentially is going to make this, it's going to double all of the y coordinates. So it really does nothing to 0, 0, right? Because multiplying 0 times 2 is still 0. So this graph still goes to the origin, but it is going to be, stretched vertically. So, it's going to look maybe like that. Okay, it's stretched up and down.